This is day 4, lecture 3. In this lecture, we're going to talk about exponential functions in various forms. Let's take a look at the first example. The first example says that the gas price in 1980 was 95 cents. The price increased at a rate of 5% each year, and they want us to determine the gas prices for the next 10 years. Well, I could find out the amount that it added on by taking the 95 cents per gallon and multiplying it by the 5% as a decimal. That would be the amount that was added on to the original 95 cents. Now, if you look at that statement, there's a common factor of that 95 cents. And that becomes 0.05 plus 1. So in essence, it's 95 times 1.05 will give me the amount in 1981. Now if I took that answer and multiplied by 1.05, I would get 1982's price, and so on. So what I would like you to do, I'll do the first few with you, and then I would like you to stop the video and complete the table. If you do 0.95 times 1.05, you should get 0.997. Now I'm rounding these to 3 decimal places. If you take that amount and multiply by 1.05, you should get 1.047. Then 1.099 and 1.154. Now at this point, you should stop the video and complete the rest of the table, and then come back and see if you've done your work correctly. So stop the video now and complete the table. Okay, I'm assuming that you've kept to your word and stopped it. If you finished it, you should have gotten 1.212, 1.273, 1.336, 1.403, 1.473, and 1.547. Those are the prices of the gasoline over that time. Now it says to look for a pattern as we work through it. Well, I showed you that pattern. If we took 0.95 and multiplied it by 1.05, that was 1981. Then for 1982, multiply that value by 1.05. That would give us the amount in 1982. And then multiply again by 1.05. That would give us the amount in 1983, and so on. So 0.95 times 1.05 to the x power is going to be that calculation, the formula that would get each of these values. Now this next part talks about finding that on a calculator. I will go over that part with you in class. Question number 2 is about population in Nevada from the years 2000 to 2006. I've gone through and found the populations for you, and then in addition to that, I've found the amount of change from one year to the next. This is the amount in 2001 to 2000. This is the change from 2002 to 2001, and so on. They asked us to determine the relative rate of change over those years. Well, remember the formula for relative rate of change. y2 minus y1 over y1. Well, y2 minus y1 are those population values that I got in the table. So this part of the table is y2 minus y1. So it's 0.073 divided by 2.020, that initial amount, and then 0.075 divided by 2.093, 0.078 divided by 2.168, and so on throughout the table. For each one of those, you would have gotten a value for that relative rate of change. Now, if you complete those, they're not all exactly the same. Stop the video now and complete your table. Okay, I'm going to go through and write out the rest of this table and then give you the values for it. 0.081 divided by 2.246, 0.084 over 327, and 0.087 over 2.411. Now, this first one, you should get 0.0361. This one is 0.0358. Notice it's different but similar. 0.0360. Again, different but similar. 0.0361. That's different except for it's the same as the first one. 0.0361. And again, 0.0361. So notice that those values are very similar as we go along. What we want to do is find a place value that I could round all of those to so that they would be the same. The only one I have to worry about is this one. If I round that to the 3 decimal places, it would become 0.036. And I could have each one of those rounded to that amount. So the rounded amount is 0.036. That's the amount that we've multiplied by each time. Just like in the example before, we multiplied by 0.05. So in order to get our equation, it's going to be our initial amount times 1 plus that relative rate of change raised to some power. So 2.02, 1.036 raised to the x power. That will give us our population. And again, you could do it on the calculator. I will go through that in class on the day that we cover this packet. Now, the next part says, to predict the population in the year 2010. Well, 2010 is 10 years from 2000. So if I use 10 for x, population equals 2.020 times 1.036 to the 10th power. That should give me the population in 2010. When I calculate that, I get 2.87706,003, and that's in millions. Now, the actual population would be this. I'd multiply this by 1 million. 2,877,060.03. So that means the population is 2,877,060 people. Again, we don't have a fractional part of a person, but in this class we will always round to a minimum of 3 decimal places. I'm going to end today's video here, and we will finish the rest of it in class.